So in the last video, we were talking about the Rodriguez formula for the for finding the Legendre's polynomials. There is of course another formula as well, which comes from the which is derived from the recursive relationship. That formula is a little bit complicated than the Rodriguez formula because it has more terms involved. So what is this formula? This formula is this. It is a in the summation series, summation sigma format. So it is sigma is equal to m is equal to 0 to m, capital M is equal to 0 to capital M, minus 1 power m, and then it is to be multiplied by 2n minus 2m factorial into x power n minus 2m, and divided by 2 power n into m factorial into n minus m factorial, or divided by n minus 2m factorial. Okay, so there are, you can see so many terms involved. So let's apply this formula to find the first Legendre polynomial. Okay, so in this case, one more thing in this formula is that m is equal to n by 2 or n minus 1 by 2. So whichever is integer. Okay, so m is an integer. M is integer. Okay, so whichever thing gives you the integer value, that will be the value of n. So if, for example, if n is equal to 1, then m will be either equal to 1 by 2 or 1 minus 1 by 2, that is 0. So from 1 by 2 and 0, 0 is the integer, so m will be also equal to 0. Okay, so in this case, so we will have a summation of from 0 to 0. So that means we have to sum only one time. Okay, so in this case, that will be then minus 1 power 0. We will start from m is equal to 0, and then that's it. And then it was 2m minus 2n factorial. Okay, sorry, it is 2n minus 2m factorial. Actually, the correct formula is 2n minus 2m factorial. Okay, so n was 1, so it will be 2, and then m was 0, so it will be 0 factorial, then x power 1 minus 0. Okay, and then that here it will be 2 power 1, 0 factorial is 1. Okay, n is 1 minus 0 factorial, and then this will be also 1 minus 0 factorial. So you can see that minus 1 power 0 is 1 times 2 factorial is 2 into x power 1 divided by 2. 0 factorial is 1, 1 factorial is 1, and 1 factorial is 1. So that is equal to x2 cancel with x. So this is what we know. Okay, so how about for the second one? Okay, p2 of x, it will be sigma m is equal to 0 to m. Okay, so in this case, what will be the value of m? M is equal to n by 2, so that means 2 by 2 or 2 minus 1 by 2. So here it is, m will be equal to 1, because 2 by 2 is 1, 2 minus 1 by 2 is not an integer, so m will be equal to 1. So we have to add two terms in this case, from 0 and 1. Okay, so here 0 and 1, so it will be minus 1 power 0, and minus 1 power 0. Okay, and then 2n, so it will be 2n is equal to 2 into 1 minus 2 into 0, okay, factorial. So x is equal to n is equal to s, because n is equal to 2 in this case, okay. So x power 2, so here it is 2n, okay. So yeah, I did make a mistake over here. It should be 2 by 2 and m was 0, okay, 2 by 2 and then n was 0. So x is equal, n is equal to 2 minus 2 into 0 and divided by 2 power n, 2 power 2, m is equal to 0 factorial. It will be 2 minus 2 into 0 factorial, and this was 0 factorial, and then 2 into 0, that is 0 factorial, and then this will be 2 minus 2 into 0 factorial. Yeah, since there are too many terms, so there is a chance of making a mistake in this type of formula. And then next is minus 1 power, now m is equal to 1, so minus 1 power 1, okay, and then 2n, 2 into 2 minus 2 into 1 factorial, so it will be x power 2 minus 2 into 1, okay, x power 2 into 2 minus 1, and okay, and then it will be 2 power n, 2 power 1, so it will be 2 power 2, actually 2 power 2, and m is now 1 factorial. Then this will be 2 minus 2 into 1 factorial, and then this will be it will be then wait a minute, actually here it is n minus m factorial, okay, so I should write it more clearly over here, n minus m factorial, okay. So if it was m minus m factorial, so here it should be n minus 2 into 0, so it should be n minus 0 factorial, n minus 0, here it was 2m, okay, and then it will be here also correction, so it will be 0, and then it will be 2 minus 2 into 1, 2, so m was 1 here, okay, m was 1 here. Now the value of m is 1. Yeah, so now it is a factorial over here, okay. So minus 1 power 0 is 1, then this will be 4 factorial, and then it will be x power 2, x power 2, x power n minus 2m, which is n was 2, m was 0, so x power 2. Okay, so and because it was factorial, so this is now 4, this is 1, this is 2 factorial is 2, and then this will be also 2 factorial is 2, and then over here now it is minus, this term will become minus now, so 1 into, and then this is 4 minus 2 is 2 factorial is 2, and then this is x power 0, that means x will vanish from here, then 2 square is 2, 1 factorial is 1, then 2 minus 1 is 1 factorial is 1, and 2 minus 2 is 0 factorial is 1. So let's see what we get. So that is 4 factorial, and then here it will be 4 divided 4 factorial, so that will be 6, and then this is 3, so it is 3 by 2, right? 3 by 2 x square, 3 by 2 x square, and then minus, this will be 2 over 2, so minus 1 by 2. So 3 by 2 is, I can take 1 by 2 as common, so it will be 3x square minus 1, so which is the same answer as before. So as you can see that we can have like we can expect that there are similar number of calculations involved, whether we are using the Rodriguez formula or this formula from the recursion relationship. So I don't think any of these formula may have any edge over the other. So but this first formula may be useful in inputting into a spreadsheet program, and then can calculate it better. But however, what we can do is we can use this formula in the Wolfram alpha, okay, and Wolfram alpha will directly give you the answer. Okay, so let me illustrate it with on Mathematica. So here I have the Mathematica, and the Mathematica function for this is Legendre P, and then whatever if we want. So for example, if you want the first order, if we will just put 1, and then I can put x and then close. So that is for the first order. Okay, if we want for the second one, so I can just put for the second one, so it is 2, yeah, and for the third one it is this one, yeah, sorry, for the third one is this. Even we can have for the 0th order, by 0th order, okay. 0th order. So 0th order is 1. 4th order is this. Okay, and we can plot it as well. So let's see this variable as LG1. So if we want to see how these Legendre's polynomial look like in plot, so I can put it in the plot command. I represent these from 0 to 4 or 4th order Legendre's polynomials as LG0, LG3 up to LG4, and then I put it in the plot command, and then now I execute it. So here is the here is how the Legendre's polynomials look like. So they can see that from the x and y range of -1 and 1, the Legendre's polynomial range between -1 to 1. But as the order of the polynomial increases, we can see that their amplitude becomes lower and lower. Okay, so there are certain properties of the Legendre's polynomials which are interesting to look at, and there is a lot of literature available about the properties of the Legendre's polynomials.